Hi, in this video, I am going to discuss with MSc Chemistry third semesters, SCT 3.4. The title of the paper is Analytical Techniques. In this paper, contain 4 blocks. First block will cover extractions and precipitations method. Under that, solvent extractions, concept of ligands, gravimetric analysis, and factors influencing completions of precipitations. These 4 units coming under in that first block. The title of the block is Extractions and Precipitations Method. The second block is titrations method. Under that, what is titrations, the principles of titrometric analysis, titrations curves for strong acid and base, weak acid and strong base, detection of endpoint, theories of acid-base indicators, acid-base titrations in non-aqueous media, titration curve, effect of water. The third block is continuations of titrations method but in EDTA titrations and Karl-Fischer titrations, redox titrations, and indicators criteria for selections of indicators. The last block of this paper is complexometric titrations. What is complex formation reactions, conditional formational constant, inorganic analysis, and organic analysis. Dear students, now I am going to introduce that course. Already you heard that word analytical chemistry. It is a branch of chemistry which implies to all experimental science. The chemical analysis involves various technologies, develops procedures, provides tool and make use of variety of instruments, and finally interpretations of the result is obtained. The various methods are used to identify the composition of a chemical substance and to determine the exact amount of the conformed constituents. The chemical analysis is subdivided into 2 broader categories. One is that qualitative and quantitative analysis. Qualitative deals with only identifications of elements. That quantitative deals with the how much percentage of elements present in that compounds. The continuations of this quantitative analysis mainly includes that gravimetric analysis and volumetric analysis. In gravimetric analysis, the substance to be determined, which we call analyte, is converted into an insoluble compound using a suitable reagent, which is collected, dried and weighed. The weight of the compound obtained are then correlated with the amount of substance originally present using stoichiometric equations. It is important that formulae of the compound should be correct now. But in case of volumetric analysis is concerned with measurement of volumes, it can be determinations of the concentrations of analyte by volume in a solution as by titration, which is also called titometric analysis. Determinations of the volume of gases or changes in their volume during combinations with measuring the volume of gases evolved or absorbed in a chemical reactions. In the first unit, that is solvent extractions. In this unit, we are going to cover that what is solvent extractions, distributions ratio, percentage extractions, separation factors, distributions law, process of distributions, extractions, chemical interactions in the aqueous phase, distributions of extractable species, chemical interactions in organic phase, coordination complex, extractions of metal chelates, selectivity in chelate extractions, batch extractions. Finally, summarize the unit. In this unit, we'll mention the objectives are like that. Solvent extractions in purifications of substance, distributions law of solvent extractions, percent extractions in the different solvent, chemical interactions in aqueous phase, ion association complexes, and better solvent to extract particular substances. Dear students, first we learn the definitions of the solvent extractions. It is a method of operations long been to shown the chemist. In recent years, it has achieved recognition among analyte as a powerful separation techniques. Consider that liquid-liquid extractions, mostly commonly used in analysis, is a technique in which a solution is brought into contact with a second solvent, essentially immiscible with the first, in order to bring the transfer of one or more solutes into the second solvent. In this analytical applications, solvent extractions may serve the following three purposes. Free concentrations of trace elements, eliminations of matrix interference, differentiations of chemical species. The procedure is applicable to both trace and macro levels. A further advantage of solvent extractions method lies in the convenience of subsequent analysis of the extracted species. If the extracted species are colored, as in the case with many chelates, spectrophotometric methods can be employed. Distribution ratio means it is the ratio of two immiscible solvents can be described by the distribution ratio. Here A1 represents the stoichiometric or formal concentrations of a substance. Since in most cases two-phase systems is of analytical interest, an organic solvent and aqueous are involved. The percent extractions is denoted by the symbol is E. The percent, the commonly used term for expressing the extractions efficiency by analytical chemist is the percent extractions. That is also related to distributions law. The percent extractions is equal to 100 into concentrations of A volume, finally 100 D by D plus V aqueous by V organic. Here V represents the solvent volume and their quantities remains as previously defined. The percent extractions may be seen to vary with the volume ratio of the two phases as well as with D. It may be seen from equation. To extreme the values of DE becomes less sensitive to changes to D. This is separation factors is used for the separations of different elements and species from each other. It becomes necessary to introduce a term to describe the effectiveness of separations of two solutes, where A and B represents the respective solutes. In those systems where one of the distribution ratio is very small and other relatively large, complete separation can be quickly and easily achieved. This is distributions law. In the simplest extractions case, the distribution ratio is constant in accordance with the classical Nernst distributions law. A solute will distribute itself between two essentially immiscible solvents, so that at equilibrium the ratio of the concentrations of the solute in the two phases at a particular temperature will be constant, provided the solute is not involved in chemical interactions in either phase. Here the deviation from the distributions law arises from two sources. They are neglect of activity correlations. Participants of the distributing solute in a chemical interactions in either or both of the two solvent phases. Consider the examples of this. The distributions of acetic acid itself may be described as follows. This is acetic acid dissociates in aqueous phase, gets acetate ions and H plus ions. Ka is equal to distributions H plus CH3CO minus by CH3COOH is what? Law of dissociation constant. But in case of benzene, it undergoes dimerization. Acetic acid, it undergoes dimerizes. The overall distribution of acetic acid is described by D only. D is equal to CH3COO organic phase in that benzene to formation of dimer. But in case of water, it undergoes dissociation. Upon incorporations of all the equilibrium expressions we get, this is that shows the distributions of acetic acid varies as a function of pH and acetic acid concentration. The process of extractions. In this, it involves some essential aspect of this process of extractions. Chemical interactions in the aqueous phase, distributions of extractable species, chemical interactions in the organic phase. These three aspects are shared by almost all extraction systems and serves as the basis of useful organization patterns. The chemical interactions in aqueous phase. The major point of differentiation between extractions of organic and inorganic material is the extent to which the formation of an uncharged extractable species depends on chemical interactions in the aqueous phase. Most organic compounds are already uncharged and extractable. Such aqueous phase reactions, if do occur, might well transform this to charged non-extractable species. In contrast, most of the inorganic compounds are dissociated so that in order to extract a species of interest into organic solvent, reactions in the aqueous phase leading to the formation of an uncharged extractable complex must be utilized. The next concept of this, distributions of extractable species. The ratio of solubility of a solute in each of two solvents may not be critically equated to the distribution coefficient of the solute between the two solvents. The underlying factors affecting relative solubility of distributions are undoubtedly similar. Therefore, useful to discuss solubility characteristics of various types of substance and to note structural effect in both solvent and solute on the solubility. In solutions where specific chemical forces are not effective, the classical principles of like dissolves like is of great help in predicting solubility. These principles may be expressed in modern terms as Hildebrand's theory of regular solutions, from which the solubility is seen to increase as value of solubility parameters of solute and solvent approaches each other. In this paragraph, we mentioned that what is solubility parameters. It is defined as the square root of the heat of vaporization per millimeter, is a measure of cohesive energy density. Comparisons of solubility parameters should be maximum assistance of dealing with those organic extraction systems in which specific chemical or associative forces are inoperative. In systems where hydrogen bonding may be present, particularly those involving an aqueous phase, the solubility parameter is inadequate in predicting the solubility. Here, the colander has been able to observe irregularities in distribution characteristics in systems involving hydrogen bonding. Yet, so many scientists to explain the concept of the solubility parameters. Consider some of the examples here. Hydrocarbon substituents will increase the solubility of chelates in organic solvents, although the neodymium chelates of cupron 1 is not soluble in chloroform, whereas the corresponding neocupron 2 soluble in chloroform. This is the structure of this 1 and 2. The polar substituents will, of course, reduce solubility in organic solvents. The chelates of 8-phenylenol 5-sulfonic acids are not all soluble in organic solvents but are quite soluble in water. Many ions association extractions are aided by the use of salting out agents. Electrolytes used in high concentrations to produce a mass action effect by adding a common ion, reduce water activity greatly, lower the dielectric constant so as to favor ion pair formation. The use of salting out against in organic extractions is also well known. The chemical interactions in organic phase naturally lower its concentration in this phase and hence improve extractability. If in case of a carboxylic acid extractions, the organic solvent is one in which acid dimerizes, this would result in a higher D value than the reactions does not occur. Ion association complexes being dipoles tend to form higher aggregates in organic solvents at higher concentrations. Where there is a polymerization reactions of any type, the value of D will be found to vary with the concentrations of the extracted material. The different types of inorganic extractable complexes. Most salts are strong electrolytes whose solubility in water can be attributed to the high dielectric constant of water, which greatly reduce the work of dissociations and solvating tendency of water, since hydrated ions experience less interionic attractions and resembles more closely medium in they are dispersed. We consider that coordination complexes. A coordination complex, as the term implies, is formed by coordinate bond in which a previously unshared pair of electrons on donor atoms or ion is now shared with an acceptor atom or ion. Three types of coordination complexes are of interest here. Consider that monodentate complexes means having only one ligand. In polydentate or cheladentate, it is having more than one donor atoms to formation of this chelate or complex, means polydentate complexes. These are all some other examples are mentioned here, chelate systems and reactive groups. Consider that ion association complexes. Here also, in ion association complexes are uncharged spaces formed by the associations of ions because of purely electrostatic attraction. The extent of such association increases sharply as the dielectric constant of the solvent decreases below 40 to 50. Here we mentioned some other examples of this. Polydentate complexes. This is ion association systems in that metal contained in cationic number of ion pair, alkyl phosphoric acids, carboxylic acid, cationic chelates, nitrate, trialkyl phosphate oxide. In metal contained in anionic number of ion pair, halides, thiocyanate, oxyanions, and anionic chelates. These are all some examples regarding to that ion association systems. In extractions of metal chelates, the equation describing the extractions of metal chelates may be derived by considering the reactions occurring when an aqueous phase containing a metal ion is contacted with an organic phase containing a chelate extractant. This is the general formula of this. The reagent will dissociate in the aqueous phase. We are getting, these are all the mathematical expressions regarding to that. The selectivity in chelate extractions. The separations of two metals with a particular reagent solvent systems may be evaluated with the above equation. The separation factors mu defined as the ratio of the values of the metal in aqueous is seen. This like. Here the Miller and Mealy list of the following stability sequences for bivalent metal ions are following here. Despite the adherence of the behavior of many reagents to the natural stability sequence for metals, a number of interesting exceptions are noteworthy. These are all some examples are mentioned here. In that batch extraction, the simple extractions procedure possible and the technique most employed in the laboratory for analytical separations involves the bringing of a given volume of solutions into contact with given volume of solvent. The most commonly employed apparatus for performing a batch extractions is a separatory funnel. Since it is relatively simple matter to add and withdraw the respective sequence phases. When performing a batch extraction, it is important to follow a few simple drop steps to separate the phases for sampling for subsequent processing or estimation. Here some other explanations are mentioned here regarding to that batch extraction. Now I will move on to that. Classifications of extraction systems. The process of metal extraction is based on the formation of neutral metal chelates. All types of chelating ligands find useful applications in metal extraction procedure. Based upon the process of extraction, extraction systems can be classified into four major classes. Chelate extraction, extractions by solvation, extractions involving ion pair formation, and synergistic extraction. In that chelate extraction, in this class, extraction proceeds by the process of formation of chelates or closed ring structures between the chelating agent and the metal ion to be extracted. Example of this, extractions of uranium with 8-hydroxyquinoline in chloroform, the extractions of iron with cupron in carbon tetrachloride. In that extraction by solvation, in this class, extraction proceeds by the process of solvation of the species which is extracted into organic phase. Oxygenated organic solvents such as alcohols, ketones, ethers and extract show some basicity because of the because of the lone pair of electrons on the oxygen atom, and can therefore directly solvate protons and metal ions and bring about their extraction. The extractions involving ion pair formation. The extraction proceeds with the formation of neutral uncharged species, which in turn gets extracted into the organic phase. The best example of this is the extractions of scandium and uranium with triacetylamine. From mineral acids. In this case, the ion phase is formed between the complex of metal ion with high molecular weight amine and anionic species of mineral acid. That a synergistic extraction, in this case, there are enhancement in the extractions on account of use of two extractant. One is uranium with tributyl phosphate as well as 2-thionyl trifluoroacetone. The methods of extractions are batch extractions, continuous extractions, counter current extractions. These are all there in the part of this methods of extractions. The factors influencing the extraction efficiency. The primary requirement of solvent extraction for separation or removal purposes is the high distribution ratio of the solute of interest. The choice of solvent, acidity of an aqueous phase, stripping, use of masking agent, salting out agent, backwashing, variation of organic state, synergistic extraction, use of organic acid media. These are all what here factors which influencing the extraction efficiency. The choice of solvent is one of the very important. The most important consideration in the selection of a solvent for use in particular extraction procedure is the extractability of the solvent of interest. The extractability of metal complexes is greatly influenced by the acidity of an organic phase. So it is necessary to assure optimum concentrations ions for maximum extractions. In this case, chelate extraction, the chelating reagent concentration is maintained constant. The distributions of the metal in a system is the functions of pH. In that, stripping removal of extracted solute from the organic phase for further processing or analysis. Use of masking agent, the extraction procedure for metal pairs that are difficult to separate. Masking or agents are introduced to improve the separation factors. The masking agents are themselves metal complexing agents which serve to prevent a particular metal from taking part in the usual reactions. The other term is what salting out agents is applied to those electrolytes whose additions greatly enhances the extractability of complexes. The functions of salting out agents would be primarily of providing a higher concentrations of complex and thus improve the extractions. by using water. In backwashing is an auxiliary technique used with influence quantitative separations of elements. The combined organic phases from several extractions of the original aqueous phase contains particularly all the desired elements and possibly some of the impurities that have been extracted to much smaller extent. Validation of oxidation state. The selectivity of an extraction is increased by the modification of oxidation state of the interfering ions present in solutions. In order to prevent the formation of their extractable metals complexes, consider examples like reductions of cerium 4 and to cerium 3 prevents extractions this element from nitrate media. Like that, here several examples we consider and to explain the thing. Synergistic extraction means synergism means that defined as the combined actions of two complexing reagents, which is greater than some of the actions of the individual reagents used alone. The example of the synergistic extraction, cerium 3 with picolinonic acid and benzo 15 crown 5. In use of organic acid media. The organic acid media are having ability of controlling the concentrations of the complexing ligand. Is one of the unique applications the ease of adjustment of the comparative study of the stripping of the complexes form. The organic phase can be achieved by fully exploiting the differences in reactivity of various metals to backwash in the aqueous phase by mineral acids. Just we summarize that topic or unit. The solvent extraction is a process whereby two immiscible liquids are very vigorously shaken in an attempt to disperse one in the other so that solutes can migrate from one solvent to the other. Okay, just we are going to summarize that. The very important keywords: distributions, ratio, percent, extraction, separation factor, distributions, everything. These are all list of reference books. Yeah, these are all the self-understanding questions that is most helpful for your practical theory examinations like distributions, ratio, percent extractions, separation factor, distributions law, extractions of coordination complex, extractions of association complex ions. Thank you.